1 minute, everybody. I am trying to load the PPT. Okay, good evening, everybody. You all can see the PPT?
Yes, sir.
Yes, sir.
Okay, great. So we'll start with the machine learning today. So anybody can tell what is machine learning? What is machine learning? Just the term machine learning.
Sir,
Anybody?
I don't know if it's my network, but we can't hear it properly.
Sorry, you can't?
It's your network, Pranati.
What she told? You are able to see the screen, everybody?
Yes, sir. She was asking if it was her network or if others
Yeah.
couldn't hear you also.
Okay, fine. So anybody has any idea what is this machine learning? There are big terms everywhere in the net regarding machine learning. Anybody can tell what it is?
So is it allowing a machine to learn a particular project or
Yes, exactly. You are making to a machine to learn, to do the things. That is what is machine learning. Though it sounds really fascinating, but yes, it is true. So we are training the machine, rather we are training the machine to learn to do our activities. Okay. So big data already we have used the small data. The small data is the data set which you used maybe for 10 lines or 100 lines. Those are the small data. Big data is which are all in the in the bytes of mega and tera. Usually mega, tera, yes, terabytes are also there, but I will rather suggest that whatever the data which you should use, it should be within the range of MBs. MBs means then it will be easy for your system to handle it. Terabytes, yes, you can also take it, but you should have a proper system to handle that terabytes. So that is what is the difference. Usually the kilobytes within like 1000 kb or less than 1000 kbs and all, you can use that you can call as a small data. Maybe few 100 lines or so on. Okay, so big data, widespread use of the personal computers and wireless communication leads to big data. We are both producers and consumers of data. This is very important. We are only producing the data. We means that is a big term like we. We means who, and again the consumers means who. Even actually we are also using the applications of big data in our day-to-day life in many ways. I will just say you few things. Data is not random. It has structure, that is the customer behavior. we need big theory to extract that structure from the data for understanding the process, making the predictions for the future. Okay, why learn? Machine learning is programming computers to optimize a performance criteria using example for the past or past experience. So what we are doing in this machine learning, that one sentence is more than enough. That is, we are training the computer with an example from the past data, so or a past experience, so that it can be geared up for the future work. There is no need to learn to calculate payroll. Learning is used to when human expertise does not exist. Yeah, it is a sentence like navigating on the Mars and so on. The you can see the robots or the payrolls which are all working there in Mars, which are actually are working on this machine learning. Humans are unable to explain their expertise, that is speech recognition, that is your NLP. Also in NLP it comes this one, speech recognitions. Solution changes in time, that is routing on a computer network, and solution needs to be adapted to a particular cases, that is user biometric. I think all these examples you might have used in some way or other in your general life. User biometrics, maybe in a companies or in the school or colleges, you might be having the biometrics. Even some places they have the speech recognition devices. And what are the other examples can you give for this machine learning in your day-to-day life? Any other examples you can give? Anybody?
Sir, our Siri and Google Assistant, Alexa, and all that.
Definitely, they are also using AI based on our search. Whatever we are searching in the first term, the Google Assistant, they are taking this, the search term, there is a keyword, and they were searching the articles related to our interest. Anything else you have our applications? In a Google Pay, I think all are using. In the tops, you will be getting most widely used payers and so on. I think you might have seen it in the Google Pay. Any other places? Any other places can you think of? In NCPI, if you are searching any particular data, so particular data set, automatically you will be getting the what you call your most searched items. In PubChem, if you are just typing the particular name of the compound, within the 3 to 4 letters, if you are typing, you will be getting the what you call the compounds of the particular same or the particular letters. If you have experience in PubChem, you can do it, you will be getting this. Automatically it happens. Even before you are typing the complete name of the particular compound, you will be seeing the particular name of the compound below. Okay, so these are the few general applications for your machine learning. Okay. What we talk about and when we talk about learning. So learning general models from a data of a particular example. Data is cheap and abundant. This is very important thing. The data is very cheap and abundant. Data warehouses, data marks, knowledge is expensive and scarce. That is what the trainers are needed. It is the data analysts are needed to analyze the data. There are so many data available. I think even in the last classes we have used a lot of data. We have used a lot of packages. In all the packages, if you see inside, there will be lot of data, lots and lots of data. So data are very cheap, but analysis is it is expensive. That is why the world needs the data analysts. Example: customer transaction to consumer behavior. People who Blink also bought outliers. You see in Amazon, you will be seeing this very common. In the Amazon, when you are searching purchasing one particular item, you will be getting some option for others also bought these items, or this is a similar items Amazon will be giving you. This is also a very important, or in your day-to-day life you will be seeing this particular example. Build a model that is a good and useful approximation to the data. Okay. So in machine learning, what we do, optimize a performance criteria using a particular example of the data of past experience. And this is an important thing. That is why I was teaching statistics I won't say rather that I was teaching statistics, but I was giving the codes for the statistics. Yeah, before that I wanted to ask, did everybody solve the codes or use the codes which I had given in the from the last class? Everybody? Any doubts? Anybody? One particular data set, one particular course I did not use in the class or play in the class. Did you all do it and could you understand it? Do you want me to go through the course again? Anybody? That is why I did not give any homework for the last class. Anybody? Why you all are silent? Why you all are silent? Anybody please reply?
We were able to do it, sir.
Okay, others? Divya, Gayatri, Shruti, Alex?
It was possible, sir.
Possible. Pranati, Rajapriya?
Sir, I couldn't do it, sir. I'll do it by this week, sir. Since I was not there in the last class.
So that is purposefully I did not give any homework for the last class. Because I wanted to, because this particular codes you will be using for the this particular classes in the machine learning. Shruti, Priyanka?
Did it, sir?
Yes, sir, tried it.
Okay. Chinmay?
Yes, sir. Yes, I was able to do, sir. Yes, sir.
Okay, fine. So those codes you will be using in the machine learning. That is the role of statistics. That is from the inference from a sample. The role of computer science. This is the efficient algorithms to solve the optimization problem, representing and evaluating the models for inference. So you have applications for this in the association, supervised learning, that is classification. I think you have done it. Supervised, then you have supervised and unsupervised learning and reinforcement learning. I think regression you have done in the last classes, association also. So unsupervised as well as reinforcement I will be taking for you in this particular sessions. Okay. In machine learning is a branch of artificial intelligence. There are two types actually. One is in machine learning, you have a deep learning and neural networks. I will take that parts also simultaneously in the subsequent classes. The deep learning as well as neural networks. Neural networks actually, when you are using the term neural networks, you are referring your own data sets or your machine as your brain. In brain also you have the neural networks. Similar manner you are making the machine as the brain. That is the term as the neural networks. Okay. So in the computational neuroscience and all, they use this particular neural networks. Okay. Machine learning is a branch of artificial intelligence. Uses the computing based systems to make sense of the data. That is extracting, fitting data to function, classifying, etc. I think all these things we have done machine learning can learn and improve with the historical data. Don't think these are historical data. These are all the previously used data. So here it is historical data. Don't take as the data from the history. Time and experience. bridges theoretical computer science and the real noise data. Anybody can tell? I think last classes somebody had told about this noise data. What is this noise data? Anybody? I think Pranati had given that answer, noise. Chinmay, can you recall what is noise? Chinmay? Sorry? Yeah, so you who was speaking can unmute and speak. Who was that?
Sir, I was speaking.
Tell me, what is noise?
Sir, noise is basic. So I had network issues, sir. That's why that happened. Noise is basically data that is not necessary. It is disturbance to the actual data that we are searching for.
Chinmay?
Yes, sir. I had also same idea, sir. It is something which is not needed, sir. Noise.
Not needed, and also something else. One more line, maybe one more letter you might be missing.
Corrupt
Think
data.
it. Anything else?
So disruptive data. It disrupts the data that is considered necessary.
Any further term? Divya?
Outliers are also
Erroneous values. Hello.
Yes.
It's erroneous values.
Nobody is telling the repeated values, repeated data.
No, sir. Erroneous values.
No, that's why I'm asking why nobody is telling repeated data. Even the repeated data are mainly the noise. I think even in the last classes I had told. Repeated data, we have to remove them. Right? Yes, even in the genomics classes, I think I had told that noise is mainly the repeated data also, which you need to remove. If you can remember in the genomics classes. Okay, yeah, these are both the unwanted data as well as the repeated data. Yeah, Jovita, you wanted to tell something?
No, sir. No, sir.
Yeah. So unwanted data or useless data, along with that, you have repeated data. In the chip sequencing, actually, initially you are telling you how much noise you are getting, if you remember. So there is noise is mainly there is the repeated data. Okay. So these are the several examples of your machine learning in real life. Okay, so supervised and unsupervised learning. In unsupervised learning, there are no predefined or known set of outcomes. Looks like hidden patterns in relation to the data. A typical example is clustering. This particular data set is mainly of this one this one you can see sepal length, flower colors, actually this one flower colors, flower length, this particular data set. Maybe we will be using a similar data sets in this particular classes in the machine learning. So that is the example of clustering. And remember, everybody, you can see that only a small data is only always given to you. As I have told you, big data, please do not try to display in the R screen, even in the computers. This is my general request to all. Big data, please do not, if you have to just click on the name of the data and press enter in R, do not do that. Always use the head command whenever you are using the big data. Big data, never try to read the data. You may read the particular data in Excel, even that will also take some time in loading. It may open, it may not open. Usually it will open in Excel, but definitely I will suggest that do not try to open in R. Your both system as well as R will get hanged. It won't get corrupt, but it will get hanged. In Excel, yes, because these are all the data you can definitely read in Excel. But see to it, if it is too large data, do not try to open even in Excel. And I have given you one data set. Could you all try to type it in Excel and what you are able to load in your R, everybody? I had given a data set of a clinical data. Anybody? If you have not done it, please try to do it. Today I will not take the data, but tomorrow definitely I will take the data and I will be analyzing it. Okay. In supervised learning, for every day, for every example in the data, there is always a predefined outcome models in relation between the descriptive features and the target. That it fits data to a function. So two groups of problems there are. You have classification and regression. That is all you have done in the last classes. But here it will be even further in the machine learning things. Sorry, the machine learning codes. Classification, it predicts the class. It predicts which class a given sample of data. In machine learning, or you will say not even from here onwards, every time it is better that you see the class of the data, because we might be changing the class of the data frequently. So it is better that before giving any particular command, check which type of data it is or data set it is. Okay. Class a given sample of data, that is sample descriptive features, is a part of the discrete value. Regression, it predicts the continuous values. Okay, yeah, this is the machine learning process. So it defines the objectives, defines measurable and quantitative goals. Use this stage to learn about the problem. Data preparation, as I think everybody knows and you have done it. Normalization, transformation, missing values, and the outliers. In the, I think I told in the regression and all analysis, you might be even taking the or getting the missing values. Then you have in model building, data splitting, features engineering, estimating performance, evaluation, and model selection. I think these are all things you have done it in parts and parts, because these are all done in the statistics. That is why machine learning is always a part for statistics. Okay, in the model evaluation, study model accuracy, work better than the native approach or previous system. Do the results make sense in the context of the problem? Then further we have model deployment. I think these all combined, and you have actually done single steps every time. That is, either you have done normalization or transformation, or you might have taken the missing values, splitted the data, and all you might have done. But in the machine learning, it is all the processes are combined. That is why whatever you have done in the previous classes, in the machine learning, all the codes will be together in the symbol, the same. And to be very frank, in the this one machine learning research papers, the papers will be very small, maybe hardly 2 to 3 pages. In the genomics, if you are doing it, genomics, your research papers will be at least 10 pages or 15 pages like that. But in the data science, your research papers will hardly 2 to 3 pages, because most of the things are statistical analysis, and you are doing with the R programming language. Okay. Okay. Machine learning as a process, that is a data preparation, needed for several reasons. Same models have strict data requirements, that is a scale of the data point intervals. Some characteristics of the data may impact dramatically on the model performance. Time on the data preparation should not be underestimated. So raw data, you can see what you have to do initially. That is, you have to find the missing values, error values, different scales, dimensionally, then you have to find the types of problems and many others. I think all you can do it now. I guess everybody can do what all the things it is said in the raw data. Then in the data transformation, you have to do scaling, centering, skewness, outliers, missing values, and errors. finally data loading, that is the modeling phase. So can I ask directly that I think everybody can do all these steps individually? Yes or no? All the codes you have, actually all the, as I'm telling in the machine learning, whatever the codes you have used, same things you will be using for the big data. You're all done the same course for the small data. Now it is the time for the big data. So in the as I told, everything you have done in the statistics, just you have to take those codes and implement for the big data and check it out. If there are any missing values, you have to put it and just check it out if the code is fitting for the particular data set or not. If it is not fitting, make the necessary alterations to make the code or the data set usable. And one more thing, and the biggest problem in this data, and the biggest problem lies in this data analysis is the datas. Datas you have to take permission before publishing it. The genomics data, they are all given in NCBI. You can take it and use it in the for the data for this data set, that is a genomic, sorry, I won't say genomic data, here it is biological data, that is the numerical data, I will say here. Numerical data, you have to take permission from the particular owner. You can contact the particular owner and you can take the data and you can use it. That is the better part. Otherwise, you can use for your project work the data, no problem. But if you are going for publication, please contact the owners. That is the a little bit tricky in the data analysis. Directly, please do not go ahead with publishing the data. Sorry, data sets. Anyway, you will be doing some additions, modifications, whatever it is. But the data set, because they are all standard data sets developed by some people, so it is better to take just write a mail and then you can use it. Okay. So machine learning as a process, that is a feature engineering, determine the predictors, that is the features to be used, is one of the most critical question. Sometimes we need to add the predictors and reduce number, that is fewer predictions, more interpretable model, and it becomes just costly. And most of the models are affected by high dimensionality, specialty for the non-informative predictors. So building predictors, you have the wrappers, that is multiple models, adding and removing the parameter, already I said. Then algorithms that use models as input and performance as output, that gives to your genetic algorithms. Further filters also you will be using it. Anyway, you have to use it. Evaluate the relevance of the predictor and based normally on correlations. Machine learning as a process, that is model building, data splitting, allocate data to the different tracks, that is model training and performance evaluation, define training, validation and test sets, feature selection, review the decision made previously, that is the data splitting, estimate performance, visualization of the result, yes, discovery, interesting areas of the problem space, statistics and performance measures, evaluation and model selection. There is no free lunch theorem, as a priority assumptions can be made here, and avoid use of the favorite models if needed for your evaluation and model selection. Okay, learning association, it is a little bit probability here for basket analysis. I think everybody knows very little probability is here. I think you all can understand. Px5, that is Px by Y, the probability that somebody who buys X and also buys Y, where X and Y are the product and services. Example, P chips per beer is 0.7. This is very simple association. So classification, that is credit scoring, they are differentiating between the low risk and high risk. Here even a customers also given, you can do for your data also high risk and low risk customers from the income and the savings. So you can see here it is differentiated as low risk and high risk. So you can see here, this is one of the example how you can classify your data based on low risk or high risk. Okay, classification applications, that is the pattern recognition. How you can do it? Face recognition based on the pose, lightning, occlusion, that is the glasses, beard, makeup and hairstyle. So this is very important, how your mobile or your punching devices use this face recognition, that is by pose, lighting and occlusions. Even the makeups and the hairstyles also it matters. Character recognition, different handwriting styles, speech recognition, temporal dependency, medical diagnosis from symptoms to illness, biometrics recognition, authentication using physical and behavioral characteristics, that is face, iris, signature, and outlier and other novelty detection. So these all things, it is like, though it is given here, it is a very, very important slide, that is the applications and how the applications are actually used. So example, you can see, check it out here, training example and test images. So how the face, you can see here, this is a face recognition. Here it is given first here as the pose. So we can see the pose of the person, how he is showing the face. Then lighting is everybody, it should be all the pictures have a good light. Then you have occlusion, that is the glasses. Here you can see same person with the glass. And then you have this makeup and hairstyles. You can see here. These all are the pattern how a particular system will be reading the images. Okay, then you have the regression. So regression, I think it was taken in the classes, still you can see it here. Example of a price of a used car, that is the price car attributes, and y, that is the price. So you are getting a particular this one graph. I won't tell you to analyze the graph, but this is how you can see here the missing data, if anywhere it is there, it can be taken, and the performance how it is coming down. Okay, regression applications you are getting in the navigating the car as well as the kinematics of a robotic arm. Don't go further figures here, just so you can get the application, see the applications. Okay, next coming to the supervised learnings, that is prediction of the future cases. Use a rule to predict the output for the future inputs. So whatever using the small data, you have taken you have got the outputs based on the same codes. You can predict the output for the future inputs and the outputs using the same codes. Knowledge extraction, the rule is easy to understand. Compression, the rule is simpler than the data it explains. And outlier detection, exceptions that are not covered by the rule, example the fraud. Okay, further unsupervised learning what normally happens, no output, clustering or grouping similar instances. Examples, applications are customer segmentation in CRM. This is customer resource manager, I think CRM. Image compression in color quantization, and in bioinformatics learning motifs. I think many of the students here, they know how to analyze the motives, how to get the motives. It is you can do with using this unsupervised learning in the machine learning techniques. Okay.
So,
Yes.
can regression analysis used for QR codes analysis?
Definitely.
Okay.
There also it is used. No, even QR codes you are reading and analyzing it.
Like which products having multiple demands and which products are sold by each shop, right?
Yes.
That kind of thing. Okay.
Yes. Yeah. That is a give. Okay. The color quantization, even the codes was given or somewhere. I think. Did I come across the codes anywhere? Okay. Okay. Reinforcement learning. What is the reinforcement? By the name only you can understand that you are reinforcing the learning. Reinforcing a particular learning. Learning a policy, example, a sequence of outputs. No supervised output but delayed rewards. Credit assessment problem. Even in game playing, robot in a maze, multiple agents, partial observability. These are a few applications. Okay. Okay, supervised learning, as I was told, it is again the regression techniques. So you have a labels like the points like x1, y1, x2, y2, and so on. Learn the function to predict y given the x is real value, that is regression. So you can see here based on the supervised learning and that is in the within the supervised learning regression techniques, you can get the or predict the missing values. That is what it is. You can see here. Classification. Given you have x1, y1, x2, y2 values, and it is for the breast cancer or malignant and beginning. Similarly, you can use the supervised learning for the classification. How you can classify the different types of cancers based on the tumor size.
But I can't hear you.
Sorry, you cannot.
Pranati, it's your net, Pranati.
Cannot see. Okay, so you can see here how it is like a tumor size. Based on tumor size, how it is detecting. Okay, so supervised learning can be even used for the multi-dimensional, that is using for the clump thickness or uniformity of the cell size or uniformity of the cell shape. So you can use the supervised learning.
Can anyone hear me? Because I can't hear anything from that time.
Pranati, it's your
Pranati can follow the YouTube, I think, directly. Pranati, if you are there, I think you can follow the YouTube. Somebody can tell Pranati to follow the YouTube then. But the only thing, if you have any doubts, you please you can WhatsApp me. Alex, you can just message her personally and see if she can overcome these problems. Okay. So in the unsupervised, how we can see that that it will be the without the labels. In the supervised, you have with the labels, whereas in the unsupervised, you have without the labels. Hidden output is the hidden structure behind the X. That is the clustering. There is one more part. It is the hidden Markov models. I think I will take little bit of that in the if at all I will be taking little bit of the genomics. There I may take this hidden Markov models. Let us see. So in the you can see the difference in the supervised and the unsupervised. This is the unsupervised here, and this is the supervised. Supervised, as you can see everywhere, you are giving the separating the particular items in the data, whereas in the unsupervised it is just a clustering. Okay, so genomics application. So group individuals by the genetic similarity. Actually, all these things, even it can be applied to the genomics also. R programming can be used. All the next generation techniques. It can be used with the R programming apart from the Linux. If anybody tells you that if at all you do not know the Linux code, you can definitely use R and you can do the NGS technique, that is the transcriptomics or chipsec or meta transcriptomics and so on. Okay, so unsupervised learning, wherever you can see later, okay, that is mainly you can say for the clusters, social analysis, wherein you don't have to separate the items in the unsupervised learning. Again, in the unsupervised, independent component analysis separate a combined signal into its original source. Okay, next part is the reinforcements, as I told in the previous ones. Okay, given a sequence of states and actions with delayed rewards, that is the output a policy. Policy is a mapping from the state's action that tells you what to do in a given state. I think the same examples I had given you: credit assessment system, game playing robot in a maze, and balance pole in your hand. Okay. So interface, that is the agent environment interface. Sorry. So how an agent can interact with the particular environment, it is given here. I will not go through the statistical parts. If you want, you can check these videos in the when you are doing it on your own. Okay. Inverse reinforcement learning, you can even check the particular video. Okay, framing a learning problem. So designing a learning system, choose the training experience, choose exactly what is to be learned, that is the target function, choose how to represent the target function, choose a algorithm to infer the target function from the experience. So you already have this trained data and you have the testing data. For whenever you are getting the trained data, you can check the particular trained data use on this for the testing purpose. That is how you are designing the learning system. First you are training the data, then you can definitely test to see its particular performance. Okay, training versus test distribution. We generally assume that the training and test examples are independently drawn from the same overall distribution of data. We call this IIDs, which stand for independent and identical distributed. What is this here? I will be telling you based on your previous course. You can take any particular course, any particular set of course and test on any different data. Every time I will be telling you test on the different data. So then you can see if it is working on, that is called as your testing. Already you have trained your R and then you are going ahead with a different data set for testing it. That you can do it. Then you can implement your big data. If examples are not independent, it requires collective classification. If the test distribution is different, it requires the transfer learning. Okay. So what you do in a particular machine learning, tens of thousands of machine learning algorithms, hundreds every year. Every machine learning has three components, that is representation, optimization, and evaluation. Okay, so various function representatives, you can check it out. Most of the things if which are done and which I think most of the things here it is not done, that is a linear regression, neural network support vector machines, then you have the decision trees, nearest neighbor case based, then you have your Bayes theorem, Bayesian networks, hidden Markov models, probabilistic, context-free grammar, that is your linguistics, computational linguistics, and Markov models. Okay. Okay. So evaluation, how you can evaluate the any particular model. Okay. Machine learning in practice. Understand the domain, prior knowledge and goals, data integration, selection, cleaning, and pre-processing. You have already done it. Learn the models, you have done it. Interpret the results, you have done it. Consolidate and deploy discovered knowledge. So all these parts you have already done it. Further, you have to do this part using the same codes. Okay, brief history, you can check it out. So from 1950s, people are using different particular instruments. This is all for your learning. You can check it out. If you want to check out with anything, you can do it. So this is for your probability further. So in the probability, you will be using the K-MERS, that is the K neural networks, decision trees, support vector machines, native Bayes, and so on. Okay, so this one I will be taking this particular further, that is the Bayesian statistics. So this is an example of a play tennis and how the data you need to separate it, like play tennis, no, players who are not playing it, player who are playing it, and so on, with based on separate attributes. So learning phases, how let is play or not play. That is all you have to do it. Temperature, you have to check it out. Humidity, you have to separate the data sets. So you can see it, all the data are separated. So 9 data are taken. In that you are separating the data based on which particular condition you need. This is like example of even in your principal component analysis. Okay, violation of independent assumption for real world tasks, and native Bayes works surprisingly well, and zero conditional probability. If no example contains attribute values during this particular circumstances, you need to do the test. Remedy, that is conditional probability, is estimated. Okay, I will take this Bayes theorem separately. Okay, clustering, already I have told you how the things are clustered. K-MERS, that is, this is the K neural networks. So here you can see how the particular, using the K neural networks, it is separated. This is your PCR, principal component analysis. This is your clustering again here. Okay, choosing the K, that is a K-MERS, defined by the application, that is image quantization plot data. This is PCA, means principal component analysis. Check the clusters. Incremental, that is the leader cluster algorithm, add one at time until the algo, that is the reconstruction error, that is the log or intergroups distances changes, and then manually check for the meaning. Okay. So based on the independence assumption, training is very fast and easy. Just requiring considering each attribute in each class separately. Test is straightforward. Just looking up tables or calculating conditional probabilities with normal distribution. In a particular generative models, performance competitive to most of the state of the art classifiers, even in presence of violating independence assumption, and many successful application examples as spam mail filtering. Apart from this, you have the Bayes can do. Anyway, the Bayes I will take a separate class later. So this will conclude your machine learning, the PPT. I will be starting the machine learning course in the next class. Please do the particular this one data what I have given you in the Excel, that we will be using it tomorrow.
Yes, sir.
But
Yeah.
when we tried running the Excel data after
Huh.
we saved something as Excel,
Okay.
we couldn't actually retrieve the data, no, sir.
Why? Why you will not be able to retrieve the data? You have to save it as CSV.
Okay, sir.
Save
I
it
thought
as
you meant
CSV.
XLS.
No, CSV. All the data which whatever I am given you, you can see the extension is CSV. So whenever you are, I think you are doing that mistake. I will show you. That data I have given you of a clinical data. That is sorry, not the clinical error. That is clinical trials data. So this format you have to save it. Can you all see it? Is it visible? Yeah. This particular format. CSV. Don't save it in this one. CSV Macintosh or MS DOS. Save it whatever the data you are getting it. Any data, not only that what data I gave in the last class. Any data, it has to be saved in this format only. Then only you can import in your R. Okay. Do not set in XML. XML also you can do it, but in R you can use this XML and then you can read it and then you can resave as a CSV. This is the general format for your any data set. Any data set whichever I will be giving or any from any source you are getting, it will be in the CSV. Sometimes it will be in the text format also. If it is in the text format, then it will be a little difficult for you to convert and use it. Actually, I don't have that particular data set saved in CSV, so I have told you to do it so that you will also get an idea how the data sets should be like in machine learning. Okay, so any the doubts you want to ask me tomorrow again, I will be taking in the same time at 6 o'clock. Maybe 1 or 2 minutes here and there. I will start at 6 o'clock only. Okay.
Okay, sir.
Anything you want to ask to me? Pranati,
Okay.
are you? I think don't think Pranati is there now. I don't know.
She's there in the meet, sir.
Okay. Okay. So any doubts from the previous class also? If not, I will be ending it for today. Okay, then I will see you in the next class. Take care. Good night.
Right, sir.
Yeah, good night.